So if we look at our spinal cord, and I'm sorry this chalk or this marker pen is not really doing a great job. But if you look at the typical spinal nerve that comes out here, you know that each spinal nerve does basically the same thing. I have a dorsal root ganglia up here, brings in sensory input to the dorsal gray, and you have the anterior horns and the intermediate lateral cell column here that take fibers out in the ventral component, ventral root. So each spinal nerve that we have in our brain or body does four things. It brings in sensory information. We call that terminology general somatic afferent. Have you heard that term before? Have you? No, never. Okay. It means general somatic information. Afferent from Latin, coming to, afro, A-F-F-E-R-E-N-T. There's also a general visceral afferent, and you probably haven't had much exposure to that at all. The general visceral afferents are coming from the viscera, the internal body cavities. In addition, as I said, there's a, I'm sorry for the light here, there's a motor component, and that's a general somatic efferent, effero from Latin, to flee or to leave. And there is also a general visceral efferent, which is autonomic. Have you any introduction to autonomic nervous system? Yes, good. So it's an autonomic functional component of the spinal nerve that goes to autonomic, primarily the sympathetic chain ganglia, to some degree the parasympathetic ganglia. So each spinal nerve, in this terrible picture and this terrible lighting, just turn the lights up, does four things. Now when we come to the cranial nerves, Mother Nature has, the cephalic region obviously is more advanced. The spinal is very regimented, you have the very detailed symmetry, each spinal nerve is basically functioning at the same level, but they've been modified when you come to the cranial nerves. And this is where the complexity results. With the cranial nerves, there's been specialization. And your chapter in Candell will use this terminology. It doesn't really define it that well. That's why I'm trying to define it up front. And in addition to the general sensory input, you know in cranial nerves you can have a very special sensory input, bringing specialized, this is called special somatic, S-O-M-A-T-I-C, afferent information. That would be vision, highly specialized, and the auditory system, which would be highly specialized. That's a special visceral afferent, special somatic afferent. And also in the cranial nerves, we would have a special visceral afferent. And what would that be? Highly specialized information from the viscera. And that would be smell, highly specialized, and taste, highly specialized. Okay, does that make sense? And last but not least, we have a very specialized efferent component, which is very confusing, which is called special visceral efferent. Special visceral efferent. This is a complex term because it refers to an innervation pattern that's based upon embryology, which you have not been presented yet. But in essence, the special visceral efferents are homologous to the general somatic efferents. The big distinction is they subserve the cranial nerves. And as we'll see in a minute, it's based upon embryology. The general somatic efferents in the spinal cord innervate myotomes, skeletal muscle groups. In the cranial nerves, the special visceral efferents innervate muscles that are derived from the branchial arches. It's a different embryological origin. The nomenclature is tortuous, but it exists. You'll see it in the Candell. You'll see it in all these textbooks. That's how it's based. So the general somatic efferent is coming, the muscles of the spinal cord are derived from myotomes. Those in the cranial nerves, most of the cranial nerves, and I have to add that caveat, special visceral efferent coming from the branchial arches. Okay. So here's, okay, that's a $64,000 question. We have all these functional components which could drive you nuts. You say, oh my God, I got to deal with all those components in one cranial nerve, and the answer is no. One cranial nerve, unlike a spinal nerve, can have one functional component or any combination thereof, and that's the complexity. So each spinal nerve was always four. The cranial nerves could be 1, 2, 3, 4, or even larger number of functional components. And these would be the functional components used. Now, there's one rule of thumb that I encourage you to think of, and I'm going to keep it very simple. You can write this, I would encourage you, in fact, to write this on your exam sheet even before you start. And that's that when you talk about several groupings of cranial nerves, cranial nerve number one, I apologize, I should have wrote something down. Cranial nerve number one, which is what? The olfactory nerve, you know that. You remember that from the early growth days. 2, the optic nerve. And 8, the vestibulocochlear nerve, are purely sensory, or afferent. They equal afferents. I'm not saying what kind of afferents, but they're always sensory or afferents, okay? So 1, 2, and 8 have to be purely afferent, sensory, okay? Cranial nerves number 3, which 3 is with the oculomotor, you saw that. 4, the trochlear, and again, if I confuse you or you've never heard of this before, don't hesitate to shout out, okay? 4, the trochlear. 6, the abductions. 11, the spinal accessory, and 12, the hypoglossal, are purely motor. They're purely efferent. Didn't say what kind of efferent, but purely efferent. The cranial nerves that are going to give you problems are going to be 5, the trigeminal, 7, the facial, 9, the glossopharyngeal, and 10, the vagus. And why is that? Because they contain both afferent and efferent functional components. Okay? So that's the rule of thumb. 1, 2, and 8, purely sensory, afferent. 3, 4, 6, 11, and 12, purely motor. 5, 7, 9, and 10, and a mixture of sensory and motor. Now, the Kandel book actually does not do a good job in discussing this. They create some confusion. They never put 2 in their flow chart. It is purely sensory. And they move 11, the spinal nerve 11, into this grouping. It's really not. So this is the correct organization. Purely sensory. And what we're going to talk about today, we're going to go through each of the cranial nerves. We're going to talk about what they do. And we're going to talk about their functional components. And by functional components, I'm going to talk about these particular groupings of functions. So we know they're afferent, we know they're efferent or combinations, but I'm going to tell you specifically what they do, specific functional components, special sensory, special visceral, etc., etc. And then I'm going to tell you, and you'll reinforce that in the lab, where in the brainstem the nuclei of origin are that control those components of each cranial nerve. Now, for example, you know this already when you've done the visual system, because you know the visual system, the cell bodies of origin, rods and cones, and the ganglionic cell layer. You understand that. You understand the auditory system, because you've already examined the cochlear ganglia as well as or spiral ganglia as well as the vestibular ganglia. It's important to bear this in mind, that sensory, afferent input, will either have their cell bodies of origin in the organs of special sense or in ganglia. The motor components will have their cell bodies of origin in nuclear groups within the brainstem. So that's what we'll be talking about. Does that make any sense at all to you? Let me show you some slides on that. That's the theme of today's lecture. Go through each cranial nerve, tell you what they do. Okay, number 1. 2, when I tell you what to do, I'll tell you their functional components. Okay? That's to say what specific, okay, it's an afferent, that's good. Is it a general afferent? Is it a special afferent? Okay? Then I'm going to tell you where the cell bodies of origin that give rise to those functions would be. If it's an afferent, it's either in an organ of special sense or in a ganglia. You know what a ganglia is, correct? And we'll talk about that in a minute. If they're motor, they will be in nuclei found within the brainstem. And I'm going to go through that in a minute, okay? So that's going to be the mantra of the day, what we're going to follow. You don't seem very convinced. Any questions? Have I confused the hell out of you? No? A very quiet group. Okay.